So we're going to be starting out with reviewing some algebra basics today. So this is the notes for R1, Algebra Basics. The unit, we just call it Unit R because it's review stuff. So it's all stuff that you should have seen before in Algebra 1 and Algebra 2. In this video, we are only going to simplify expressions with exponents, although our learning target is both simplifying expressions with exponents and radicals. So just a little bit of background. Um, Information and expression has numbers, variables, and operations. So when we have an expression, we can simplify it or evaluate it if it's just numbers. So an expression has numbers, variables, and operations like adding, subtracting, or exponents or radicals. Now, the thing that makes an equation different is that an equation has an equal sign. So in this unit, in unit R, we're just reviewing simplifying expressions. In unit 1, we're going to be solving all types of equations. So those have an equal sign. Now, when we're dealing with equations, there's two types of equations. There's one variable equations. So they have to have an equal sign to be an equation. To be a one variable equation, it will just have one variable like x. So an example would be like 2x minus 5 equals 7. This would be a one variable equation. Or even something like x squared plus 5x plus 6 equals 0 is also a one variable equation. So even though it has the x squared and the x, the only variable is x, and it has an equal sign. So we'll see more of one variable equations in unit 1, and we can solve one variable equations, meaning we can find the number or answer that makes the equation true. Now later in unit 2, we'll also see two variable equations. So those would be equations that have two variables. Often they have x and y. So something like y equals 2x plus 3, that would be a two variable equation. It has an equal sign and it also has an x and a y. Or even something like 3x minus 5y equals 2. This would be a two variable equation as well, because there's, again, an equation has an equal sign and it has x and y. We'll see two variable equations in unit 2. Those we can graph or look at how the variables are related. All right, but like I said, in R1, we're just going to be focusing on expressions, so simplifying those. And specifically today, we're just looking at exponents. Right, so first, in order to be able to simplify, we have to know our rules of exponents and how to simplify exponents. So I'm going to give you the rule, and then I'll give you a simple example for each rule. Okay, so rule number 1. The product rule for exponents is if we have something like x to the a times x to the b power. So notice they have both the same base of x. The rule for this is we keep the base and we can add the exponents. So x to the a plus b. So an example of this would be like if we had x to the 5th times x to the 2nd. We would keep the base and add the exponents. So x to the 5 plus 2 power, which would give us x to the 7th. So that's what the product rule for exponents looks like. Keep the base and add the exponents. We also have a quotient rule. So if these are divided, x to the a power divided by x to the b power, the rule for that is keep the base and subtract. So x to the a minus b. So for example, if we had x to the 5th power divided by x to the 2nd power, this would equal x to the 5 minus 2 power. We would subtract, and that would give us x to the 3rd power. All right, Rule number 3 is if we have a power to a power. So x to the a to the b power. So I'm raising something with a power to another power. The rule is keep the base and multiply the exponent. So that would equal x to the a times b power. So for example, if we had x to the 5th to the 2nd power, we would keep the base and multiply. So I'd have x to the 5 times 2 power, which would give us x to the 10th power. Okay, so that's the power to a power rule. Number 4, hopefully we all remember this one. If we have anything to the 0 power, x to the 0 power is just 1. Anything to the 0 power is just 1. It doesn't matter what the base is. So example, if we had 5 to the 0 power, it can be any base, is just going to equal 1. All right, rule number 5 is if we have a negative exponent. A lot of people forget what to do if we have a negative exponent. So say we have x to the negative a power. The rule for that is I say jump the line and switch the sign. What I mean by that is that this is going to become a fraction. So it's going to move to the bottom of a fraction line, a fraction bar, and we're going to have 1 over x to the a power. So the power, now we don't write it as a negative anymore, but it does become a fraction, 1 over x to the a. So for example, if we have x to the negative 5 power, this would be 1 over x to the 5th power. So it jumps the line to the bottom of a fraction and becomes positive, so changes sign. So 1 over x to the 5th. All right, and then we have 2 more rules that apply if we have 2 different bases. So the rules we saw so far only have one base of x. Now, if there's 2 different bases that are multiplied, like xy to the a power, the rule for this is we have to raise everything in the parentheses to the power. So this would be x to the a times y to the a. So they'd still be multiplied, but they would both be to the a power. So for example, if we have something like 3x to the 4th power, notice that 3x is in parentheses. I have to do the 3 to the 4th power and the x to the 4th power. So I have to do everything in the parentheses to that power. We could leave it like this with the 3 as an exponent, or we can evaluate it out. 3 to the 4th power, or 3 times 3 times 3 times 3 gives us 81 x to the 4th. And we have a similar rule to number 6, but rather than the 2 bases being multiplied, the same rule applies if they are divided like this, x divided by y, or x over y to the a power. This is equal to x to the a over y to the a. So again, the 2 bases are different, but I'm raising everything in the parentheses to the a power. So for example, if we have x over 5 squared, x over 5 to the 2nd power, I can raise everything in the parentheses to the 2nd power. So I'd have x to the 2nd power over 5 to the 2nd power. You could leave it like this in exponential form, or since we can evaluate this base since it's a number, so that'd be x squared over 25. All right, so those are the exponent rules that we use. Most often we use them when we are like multiplying 2 polynomials together or dividing 2 polynomials. But they are good to recognize and know. All right, so now let's use those to do a few examples. We just have a few. So we saw an example for each rule separately, but now if we look at our examples here, these are all using more than one rule. So on these examples, example 1, we're trying to simplify and leave only positive exponents in your answer. So example A, I'm trying to simplify a to the negative 2, b to the 3rd to the 4th power. So the first rule I have to use here is rule number 6, where I have to raise everything in the parentheses to the power. I can't combine these two bases because they're different. This one's a base of A and this one's a base of B. So, but I can put both parts in the parentheses to the 4th power. So it would look like this: A to the -2 to the 4th, and then B to the 3rd to the 4th. Okay. So I used rule 6 to put those both to the 4th power. Now I have to use the power to a power rule. That's rule number 3. The rule for that is keep the base and multiply the exponents. So this one, a to the -2 to the 4th power, becomes a to the -8. And this one, b to the 3rd to the 4th, becomes b to the 12th. All right. I'm almost done, but the last thing I need to do is use the negative exponent rule. So this one has a negative exponent, a to the -8th power. One way we can think of this is we can write this as a fraction. So this would become 1 over a to the 8th power. Now it's still multiplied by b to the 12th. So I can write b to the 12th. If I want to write that as a fraction, I would just put the b to the 12th over a 1 because it doesn't have a negative exponent. And then if I am putting these together or multiplying them together, we multiply the numerators together. So 1 times b to the 12th is b to the 12th in the numerator. And then in the denominator, I multiply those together. So a to the 8th times 1 is a to the 8th. Okay, and that's what our simplified answer looks like. I know that it's simplified because there's only one of each variable. There's only one a and there's only one b. And there's no negative exponents. Okay, so let's look at example B. We have 5x y to the 5th over 17 to the 0 power. Now we can think of it like we did the previous problem and raise everything in the parentheses to the 0 power, including the number. So 5 to the 0 power, x to the 0, y to the 5th to the 0, and 17 to the 0. But we don't even need to do that. This whole thing is to the 0 power. And so we know any base to the 0 power is just equal to 1. So that one only required us to use the 4th rule, where x to the 0 power is 1. All right, and the last example that we'll do here in the notes is putting these together. I have 6x to the -2 y cubed over 2x to the -4 y to the 6. So the fraction bar here means we're dividing. And notice I have 3 types of terms. I have numbers, I have x's, and I have y's. In order for this to be simplified, I need to put the x's together, and I need to put the y's together, and I need to put the numbers together. So I'm going to do each part separately. So for the number part, we have 6 over 2. That just means divide. So 6 divided by 2 is just 3. For the x's, I have x to the -2 divided by x to the -4. So the rule for dividing is we're going to keep the base and we're going to subtract the powers. But you have to be super careful with your signs because we're actually subtracting a -4. So I have x to the -2 minus -4. So I'm subtracting negative. That actually ends up as x to the +2 power once I simplify. So even though it had negative exponents, once I simplify, it does not anymore. And then I need to also divide the y's. So I have y cubed divided by y to the 6. So keep the base and subtract. So we have y to the 3 minus 6 power, which gives us y to the -3 power. All right, so this is what I have now. These were all next to each other, so they're still multiplied. 3x squared y to the -3. So I put the numbers together, the x's together, and the y's together. Last thing I have to deal with is the negative exponent. The 3 and the x squared do not have negative exponents, so I don't need to do anything with that. The only thing I need to deal with is this y to the -3rd. So one way to think about this, rather than writing it as a fraction like we did in A, I can also, I like to say jump the line and switch the sign. So that means this is going to jump to the bottom of a fraction and become y to the positive third power. So jump the line and switch the sign. So y to the negative third becomes y to the positive third on the bottom. So C, our final answer, is 3x squared over y cubed. And that's what our simplified answer looks like. And we know it's simplified because there's only one number term, one x term, and one y term, and there is no negative exponent.